The LiDAR is attached to this black plastic bracket. The M6 screws are attaching the black plastic bracket to the chassis. So I'll loosen these up to show how it's attached. Basically, these T-slot nuts are going into the T-slot, of course, and these are 10mm M6 bolts. And then on the bottom of the plate, you have the M3 screws. I think those are 10mm long M3 screws. And you can see, if you look closely, that the screw has this little gap to pass through, and then it goes into the aluminum housing, which is threaded on the LiDAR. And these holes here need to be countersunk just a little bit. If you make your plate out of acrylic, then you have to manually countersink these. But if you 3D print this, then it should have that designed into the 3D print. Then this connection on the LiDAR. First of all, this whole bracket can swivel. So I can't swivel it right now, but you can see that it rotates. And you want to have yours pointed down so that the wires can point downward. This cable is for the power, and this cable is for the communication. In this case, we're going to use the USB communication, whereas probably the more common connection is this one for communication. But since we have the USB available on our Beagle, we're using the micro USB, which looks like this. Obviously, just a regular micro USB connector. These go in, and then you need to make sure that the LiDAR is basically in the center of the extrusion. Once you're ready to take any precise measurements, then you should measure that you're halfway down from the end of the extrusion here. This can just be finger tight using the long end of the wrench. Don't tighten it down more than that. You'll crack your plastic, and it's that easy.